Welcome, ladies and gentlemen, to another edition of Binary Life, a channel that teaches new developers how to code by solving algorithms, and then you can see the thinking process from there and see how solutions come to life. Today we'll be solving a project. We'll be solving a Project Euler algorithm. Project Euler is a website that has tons and tons of algorithms, hundreds and hundreds, maybe thousands of them. Let's go to page 14. It's up to 600 and maybe moving up to 1,000 if I continue. That's it. And today we'll go back to the first page and solve problem number 2, which talks about even Fibonacci numbers. So each new number in the Fibonacci sequence is generated by adding the previous two numbers. That's it. And if we look at 1 and 2 here, if we add 1 and 2 we get 3. If we add 3 and 2 we get 5. If we add 3 and 5 we get 8 progressively. So by starting with 1 and 2, the first 10 Fibonacci sequence will be like this. So what do we have to do? By considering the terms in the Fibonacci sequence whose values do not exceed 4 million. So let's generate something like this up to 4 million. Find the sum of the even value numbers. So we're going to add 2 plus 8 plus 34, just the even numbers. So there are 3 things to know here. The first one is that we need to be able to generate the Fibonacci sequence. Secondly, we need to be able to stop at the Fibonacci sequence, which is the highest, being 4 million here. And then we need to be able to get the sum of the even numbers in that sequence that will generate that ends at 4 million. The first thing I'm going to do is this thing has been solved several times, Fibonacci sequence. I'm just going to look for the algorithm online, and then we're going to tweak our algorithms to match the specificities of this algorithm. I think I'd searched for one before. Oh, not really. Anyway, I'm just going to say Fibonacci sequence JavaScript. I just get the algorithm. Right, I'm going to get this one. Let's see how it looks like. So this is a Fibonacci sequence. This is the algorithm here. This one uses a for loop. The first one is so this is the description here. It starts at 0 and when so 0 plus 1 is 1, 1 plus 1 is 2, 1 plus 2 is 3. So he starts with 2. It's the same logic like our algorithm here, like the description here in the exercise, just that he starts with 0 and 1. This one starts with 1 and 2. So let's be careful. I think generally it starts with 0 and 1, and then the sequence goes from there. So if we copy this algorithm, we'll have to tweak it. So this is it here. Basically what I'm going to do is I'm going to copy this algorithm first of all here, and I've created a file on my VS Code here called Euler project2.js, and I'm going to paste the solution there and format this thing so that it looks a little bit cleaner. Now let's forget about this. This is my link that wants me to be ES6 specific. I will just be for some cases, not for every case. Let's just put a let instead of a var there. And it doesn't want me to use I++. Let's just leave it like that. Forget about the linting problems. Now I'm going to console the log. I'm going to test that algorithm and see how it works. So I'm going to call that algorithm Fibonacci of 10. Let's just be sure it works. And I'm at the level of my directory here. I'm going to call that file. Fibonacci of 10 is 89. Why is 89? That's the first 10 Fibonacci numbers, and the 10th Fibonacci number is 89. Yeah, I think the first number should be, if I'm not mistaken, the first number was supposed to start at 1 and the second one starts at 2. I think that was the case. Let's try again this thing. The tens is 233. Let's check this thing here. I'm not getting something. He starts at 0 and 1. Let's look at this algorithm again. Okay. It starts at the first number is 0, the second number is 1, and then the sum is this. When he gets the sum, he switches. Number 1 becomes number 2, and then number 2 becomes the sum. Yeah. One, two, three, four, five, 6, 7, 8, 9, 10. So the algorithm starts like initializing this. So our first sum becomes 1. Yeah. That's it. Our first sum becomes 1. So it feels like it starts at 0 and 1 here, but actually it starts at 1 and 2 because our algorithm initializes these two values already, and then enters a for loop and does the first sum, which is 0 plus 1, which becomes 1. That's the first sum, and then the number switches, and we have 1 plus 1, 2. That is why this algorithm, it's actually what we wanted. That's cool. So what is our 10th algorithm, our 10th Fibonacci sequence? Our 10th Fibonacci sequence is 89. So we've gotten the algorithm that gives us our Fibonacci. That's the first start. The second start is that we have to end at 4 million. So I'm going to do some couple of tests. If I do the first 100 Fibonacci numbers, what is it? We get more than 4 million. I'm going to come back a little bit behind and get maybe 50. That's a little bit still much. I'm going to get the first 30, the first 25. Sorry about that. Okay, like this. How much is this? Is 100,000. So it should be around the 30 spot. Let's get 30. This is 1 million, right? So you see, we're doing through trial and error, but I can do certainly an if condition there. Like I keep doing the Fibonacci until I get to 4 million. It's still possible to do that, but I just want to make it simple. So let's try 35. The 35th Fibonacci number, what's that? It's around 14 million. So we're not far. Let's get to 33. It's around 5 million. We're closing. Let's get to 32. That's 3.5 million. So 3.5 million is less than 4 million. Remember, we have to stop at 4 million here. So let's get to 33. It's 5 million. Which means that it's at 32 that we need to stop. The 32nd Fibonacci number is 3.5 million, around 3.5 million. That's it. We need to get the 32nd Fibonacci number to have our sequence of up to 4 million. That's it. And then from there, we get the sum of the positive numbers inside there. Right. So I'm going to create, this is a second function. So this function is just a pure Fibonacci, the pure Fibonacci function. But I'm going to create another function here. I'll just call it the Euler project 2. Now the Euler project 2, what does it does is it has a limit. It has a limit of 32. It also has a function. It has a constant, if you wish, that limits at the 32nd Euler function after doing our test here, so that we can end at 4 million. And then So we're going to call our Fibonacci. That's here. And n at the limit. I'm putting at as a constant so that we can change anytime we want. And n at our limit. But we'll not just end there. What we'll do is here we just return the 32nd Fibonacci number, but we'll actually need the sequence. Or we can do the sum here. Anytime we get the sum, if it's even, we count. So I'm going to modify the Fibonacci sequence just a little bit. And I'm going to create a variable. Like our even count starts at 0. Like I said, forgot about the linting. Okay, our even count starts at 0. Now anytime we get a sum, we're going to check if the sum is even. Like if the sum is even, like if you divide by 2, the remainder is 0, and then we're going to increment we're going to take that number, that sum, and add to the even count. So it will be equal to, we take the even count and add it to, and add sum to it, something like that. That's it. And at the end of the day, instead of returning the highest Fibonacci number, the last number, we're going to actually return the count of the even, something like that. That's it. So I'm going to return this, return the sum of the Fibonacci. So our new function changes. So this is sum of even Fibonacci's. Yeah, up to our number, and then we call it below here, up to our limit. It returns our even count. So let's try that, and I'm going to comment this. It's not more useful, it was just for testing purpose. Before returning that, I'm going to do a console log so that we can be sure that it works. Console.log. Yeah, right. So let's call our function again. Nothing is displayed. Why is nothing displayed? Because we haven't called this. These are two functions in a file. We need to call the last one like this. All right, let's call by this. We get this number. I don't know how right it is. In order to know how right it is, let's try to test this thing for a very small scenario. Like this is our exercise. Let's come back to our exercise. Let's limit at the first 5 Fibonacci numbers, 1, 2, 3, 4, 5. So let's redefine our limit to be 5. Yeah. So if I call this function here, what do we get? We get 10. Why do we get 10? Because if we look at our first 5, that there are 2 even numbers, 2 and 8, that gets 10. Let's increase it a little bit. Let's end somewhere here. 1, 2, 3, 4, 5, 6, 7, 8. Let's limit our Fibonacci to the first 8 numbers here. And let's call back this. We get 44. That's right, because for this interval we have 34 here plus 10, which is 44. So our algorithm seems to have worked, and this is it here. Right guys, this is our algorithm here. So the first part is that, let's start from the beginning. We copied the Fibonacci algorithm. We did that very well. And then instead of returning the last algorithm, the last Fibonacci number, we actually return the sum of the even part of it, because as we are doing the sum, we just verify if that sum is even, and then we increment our even counts. At the end of the day, we return our even count. So we can call this function with our right limit, but for our particular algorithm, our limit is 32. All right guys, thanks for viewing, and see you with another algorithm where we're going to learn other things. But here I'm going to finish this algorithm by returning. That was what the initial exercise asked. So the heart of this algorithm is the sum of these even Fibonacci numbers, and this limit is just to make us to end at the fourth million. And this is our answer here. Nothing on the screen because I haven't console log anymore. Anyway, this is the algorithm we've tested, and we've seen that it works. So guys, thanks. Don't forget to subscribe, and we'll be solving other Euler projects in the coming future. And have a nice day.